Nice. Okay. Which of the following data sets is not continuous? If you are not continuous, you're considered discrete. That means you will have exact values and we describe that as like shoe size is discrete. So shoe size is not continuous. So when I look at this, I have to think about measurement. Are there different ways to measure the gallons of gasoline in a car? Are there different levels of accuracy I could use? That's continuous. Okay. The time it takes to commute in a car. Have you ever watched the Olympics and how the time goes, they go down to more and more accurate places in the time? Okay, so that's continuous. How about the number of goals scored? That's discrete. This is discrete data. So this is the data that is not continuous because it is discrete. Hello, ladies. Say it again.
Like, what did you say the definition of continuous is?
Continuous data, I don't know what the exact definition is, but I think about it as something that can keep, the measurement can get more specific, more specific, more specific, and keep changing based on how accurate a measurement you want to take. That's continuous data. You would have all the tiny little increments. But for number of goals, you either have 0 or 1 or 2. There's no way you can have 2.5 goals. 2.23575,149. You can't have that number of goals. All right, Mrs. Burns teaches 2 calculus classes. Her morning class has a mean average of 78 and a standard deviation of 6 at the end of first semester. Her afternoon class has a mean average of 83 with a standard deviation of 9. Assuming both classes are independent of each other, what is the new standard deviation for those combined classes? I feel like this is something we keep missing. We're going to talk about this tomorrow when we go over our quiz. But it is the square root of each standard deviation squared added together and square rooted. So it is the square root of 6 squared plus 9 squared. So it is the square root of 36 plus 81. So that's 117. And it's the square root of that. So it's 10.8. So it is B, 10.8. Now, remember, you will never subtract standard deviations. If you wanted to know the difference in these 2 classes, we would never subtract standard deviation. We only add. Okay, what was the question? No? All right. If 2 random variables, x and y, are independent, find the mean and the standard deviation of 2x plus y if they give you the mean of x and the mean of y, the standard deviation of x and the standard deviation of y. This is the right after tonight's homework. It's the first review. I'll show you what it looks like at the top. It looks like that. Okay. So I have that my new mean would be 20. Does that make sense to you that my new mean is 20? It's 2 times 6 plus 8. All right, so then I'm going to get rid of these options that do not have 20. So now I'm looking at 3 options. So I can do 2x's, which is 0.5 squared. Another way I could have written that was 0.5 squared plus 0.5 squared plus 0.6 squared. I didn't have to write the 2. If that 2 in the front freaks you out, I didn't have to write that. Yes, ma'am. Oh, yes, ma'am. It is squared. Thank you. It is squared. So that's a square root of 0.86, which is 0.927. So that would be not here. Did I do something wrong? .86 to the 0.5, enter, 0.927. Oh, I did this wrong. Poop lickers. Okay, hold on. This I should have done 2 times 0.5 and then squared it. My order was all wrong. Because you're doubling the x. So when I double it standard deviation, and then I'm going to square it. Is there not? 2 times 0.5 to the second power plus 0.6 to the second power, enter. I got 1.36. To the 0.5. It's 1. It's sketchy. Oh no, it's this one. It's E. Sorry guys, it's E. I can't believe I did that. I didn't even think about it. Okay, so moral of the story, this isn't just 2x. You first do 2 times the standard deviation, and then you would square that and add the y's, and then square root the whole thing. Okay, and I did that wonky order. I would have messed that up. So that's E. All right, numero quattro, kiddos. A marketing survey compiled data on the number of cars in households. If X equals the number of cars in a randomly selected household, and we omit the rare cases of 5 or more cars, then X has the following distribution. Is this what we did today? Yes. Okay, so what is the probability that a randomly selected household has at least 2? Okay, talk to me about what at least 2 means. 2 or more. So at least 2 means 2 or more. So then you're going to add 2, 3, 4, 5 together. So 0.2 plus 0.11 plus 0.05 plus 0.03. So that gives me 0.39, which is D. And number 5 says, using the probability distribution in number 4, what is the expected value of the number of cars in a randomly selected household? So remember, your expected is your value times the probability of that event, and it's the sum of those. On the formula sheet, I think it's the sum of xi pi. Okay, so it is 0 times 0.24 plus 1 times 0.37 plus 2 times 0.20 plus 3 times 0.11. I could stop and just put plus dot 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 and get my answer and would be okay. Because you can use your calculator on this and you just have to show them the idea of what you are doing. What, honey? Yeah, so hold on one second. I'm going to finish this because I'm in the middle of it. Okay, so I have 1.45. And I'm going to show you on a graphing calculator. You could put this into list 1. And you could put this into list 2. And then you're going to go stat, calc, 1 var stat with list 1, and then a frequency of list 2. So it will say list, and you put list 1, and then frequency is list 2. And you hit enter, and it should give you 1.45. I would do that if I had a really big data set. I'd let my calculator do it. Okay, were you happy campers with this? All right. A dealer in Las Vegas selects 10 cards from a standard deck of 52 cards. Let Y be the number of diamonds in the 10 cards selected. Which of the following best describes this setting? Is this a binomial distribution? It depends, right? Does he put the card back? It's a binomial if he's replacing the card each time. If he replaces, shuffles, pulls out a card, replaces, shuffles, pulls out a card, that's binomial because the probability of getting a diamond is not changing. So the answer is C. Yes, Y has a binomial distribution with n is 10 observations and a probability of success of 0.25, provided that after selecting a card, it is replaced in the deck and the deck is shuffled. So C, if they don't talk about replacing the card, it's not a binomial distribution. Number 7. In the town of Lakeville, the number of cell phones in a household is a random variable W with the following probability distribution. The standard deviation in the number of cell phones in a randomly selected house is, I put this in my calculator and I'd do 1 var stat. So I would make this list 1, this is list 2. Did you get D, 1.32? Now, I want to talk to you real quick. Remember, if this is a free response question, it would be a pretty easy free response, but you have to show that you know you are taking 0 minus the mean, which is 2.55, and you're multiplying it by the probability and squaring it. Plus, you're taking 1 and you're subtracting 2.55 and you're multiplying it by the probability of that event, and then you're going to square it. Plus dot, dot, dot. You don't have to show them a ton, but you have to show them a little bit. That I know this is what you do. You take the value, subtract it from the mean, multiply by the probability, and you square it.
So if you get the answer right, but you don't show your work, you won't.
They're probably going to give you a P at best. Okay? So what could give you an E would drop down. Actually, I'm a little worried about this, guys. I think this might be, the square is here. Isn't that right? And then you multiply it. Give me a minute, I'm going to look at that. Okay, go ahead and do the next one. Yes. It says it's on the distance, 0 minus 2.55 squared. Yeah, I knew that felt funny when I was writing that second set of parentheses. It is here, guys. Fix that. I'm just messing up left and right today. I think it's my hot glass. Okay, so I won't mess up this next question at all. A random variable y has the following probability distribution. The value of c is, well, how do you know what it is? You know it has to equal what? 1. This has to equal 1. So we know that 4c plus 2c plus 0.07 plus 0.03 has to equal 1. So 6c plus 0.1 equals 1. .15. These two added together gave me the 0.1. I added those together and they gave me 0.1. Then I subtracted it and divided it. All right, take a look at this next one. We kind of looked at this question earlier. It talks about the variance. Remember, variance is the standard deviation squared. So we are talking about the variance here. So I see 2 of these I can eliminate immediately, A and C. I know I can eliminate A and C because they're not squared, and the variance is the standard deviation squared. So B and D are exactly alike except this statement. Is that statement necessary? Is it important that they are from independent populations? Yes. Notice right back here. So hold on. So that the answer is D, and I want you to look back at this question. I know, oops, it's this page, sorry. Right here, assuming both classes are independent of each other. 2 random variables are independent. Do you see how they keep stating it? They wouldn't state it if it wasn't important. They have to be independent for you to calculate their standard deviation or their variance. Then you can't do it. All right. It is known that about 90% of the widgets made by Buckley Industries meet specifications. Every hour, a sample of 18 widgets is selected at random for testing, and the number of widgets that meet specifications is recorded. What is the approximate mean and standard deviation of the number of widgets meeting specifications? So this is binomial. Let's talk about why it's binomial. You have 2 options. You either meet or you do not meet, correct? Each widget is known to be independent. That makes sense that one widget does not affect another widget. If one passes, it doesn't mean another one's going to pass or fail. And how many widgets are we looking at? 18 is the set sample size. And S, the probability each independent widget you look at is going to pass is going to be 0.90, is the same probability. That's how I know that this is a binomial distribution. And I know there are two formulas on my formula sheet. Mu sub x is n times p, and the standard deviation sub x is the square root of n times p times 1 minus p. So mu sub x is 18 times 0.90. Standard deviation of x is the square root of 18 times 0.90 times failure, 0.10. 16.2, so I know this can go, and I'm looking at these three. And I got 1.27279 blah, 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 blah. And the answer is D. Yes, ma'am.
I'm just kidding. I thought about this earlier. I was like, what is the difference between multiplying 0.9 and 0.10 versus 1? But then I realized you're multiplying and not adding.
Yes.
Okay.
Good deal. All right. Next question. A raffle sells tickets for $10 and offers the prizes of 0, 500, 1,000, and 2,000. Let C be a random variable that represents the prize of the raffle drawing. The probability distribution of C is given below. The expected profit when playing the raffle is profit. Notice how it's bold. Can you have a profit that is negative? Yeah, you can have a negative profit, right? That means you lost money. Okay, so number 11, be very careful, because if you win $0 off of a $10 ticket, what was your profit? Negative 10. That kind of maybe played into what you were doing today on that free response question. Okay, $500. If you win 500, but it cost you 10 to play, how much did you really win? $490. And if you win 1,000, but you had to pay $10, you won $990. And 2,000 would be $1990. Now find your expected profit. You multiply negative 10 times 0.60 plus 490 times 0.05 plus 1,000 times 0.13 times 990, my B. I have that my expected profit is $585. Let me make sure I'm right, because you know I could have messed that up. And I have $585. Perfect. Let the random variable x represent the amount of money Carl makes tutoring statistics students in the summer. Assume x is normal with a mean of 240 and a standard deviation of 60. The probability is approximately 0.6 that in a randomly selected summer, Carl will make less than about. We haven't seen this, have we? This hasn't come back up. No, it did come up once because I remember doing it. So my mean is 240 and standard deviation is 60. And we have a probability of 60%. There's a 60% chance that he will make less than some value. So I have a probability, and I'm told that this is 0.60, but I don't know this measurement. It is inverse norm. Inverse norm, my area is 0.60, my mu is 240, and my sigma is 60. If we needed the mu or something and we were going to have to use the z-score formula, we could at least get a z-score with this. I have $255.20, and that answer is C. All right, patients receiving artificial knees often experience pain after surgery. The pain is measured on a subjective scale with the possible values of 1 to 5. Assume that X is a random variable representing the pain score for a randomly selected patient. The following table gives part of the probability distribution. Find the probability that X equals 5. Well, what do we know about all of these? They have to equal what? 1. So we know these have to equal 1, so you're going to solve for the missing term. All right, so I have that it's 0.1. Yep. Find the probability that the pain score is less than 3. If it's less than 3, success would be what? Success are 1 and 2. So I want the probability of 1 plus the probability of 2. So that's 0.1 plus 0.2, which is 0.3. That's pretty exciting. The mean, the variance, and the standard deviation. Where do I get that?
Y equals, it's like it's on the chart, the not of something.
Okay, we're going to plug it into our calculator. List 1, list 2. So list 1 and list 2, plug that in, and then you're going to just do 1 bar stat, where list 2 is your frequency. So this becomes your frequency. Remember, this is a probability of 0.1 right here. I don't know why I just spelled frequency wrong, but that's kind of what I've got going on today. So you'll do stat, calculate, one far stat. And you should get, I'm going to write them, but you do it with your calculator. Make sure you can pick it out. Your mean is 3.1. Your standard deviation is 1.1358. And the variance is that squared. So it's 1.1358 quantity squared. And it's 1.29 is my variance. Because my variance is always my standard deviation squared. Yes, ma'am.
Oh, that's fine in the regression line. Just kidding. I remember it now.
Yeah. Okay. All right. Suppose the pain scores for two randomly selected patients are recorded. Let y be the random variable representing the sum of the two patients. So if I want to find the mean of y, then it's my sum of my two patients. What can I expect my first patient to be? What can my first patient's pain score be expected to be? 3.1. And what can my second patient be expected to be? 3.1. So I would expect the sum of the two to be 6.2. And standard deviation. Well, that's the first patient, and the first patient's standard deviation is 1.1358 squared, and the second patient, the same thing. So that's 1.606. So did the standard deviation increase or decrease when I put more patients in the mix? Did it increase or decrease? Increased. Hold on, I'm recording. She said she has a doctor's appointment. I'll text her. She's one of my favorites. Okay, if a player rolls 2 dice and gets a sum of 2 or 12, he wins $20. If the person gets a 7, he wins $5. The cost to play the game is $3. Find the expectation of the game. Well, we want to know the probability of getting a 2 or a 12. And what is the probability of getting a 7? So I kind of have to do a sample space because my brain isn't that great, and that's what helps me be really clear. So I could roll a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 then a 5, a 1 then a 6. 2, 1. What's this called? 2. Did I just say it? Yeah, this is your sample space. Then I could get a 3 and a 1, a 3 and a 2, a 3 and a 3, a 3 and a 4, 3 and a 5, a 3 and a 6. A 4 and a 1, a 4 and a 2, a 4 and a 3, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and then finally this is my last one. This would be kind of an interesting tattoo, correct? A sample space, you know, that way I can have my table of values, I can have sample space for 2 dice. You know, it would save me a lot of writing because I do write this a lot. All right, sum of dose. How many ways can you get a sum of 2? This is the only way. But we also need a sum of 12. How do we get a sum of 12? 2 6s. So how many ways are there to win, or what's the probability of getting a 2 or a 12? 2 out of 36. Okay, so that's a 2 out of 36. I'm going to win $20. If the person gets a 7, he wins $5. So the person gets a 7. What's my probability of getting a 7? 6 out of 36. I'm going to win $5. But this is the problem. I have to pay to play. So instead of me really winning 20, I'm really only going to win 17. So this is really 17 because they're going to give me my $3 back that I just paid to play, and then they're going to give me they're going to give me 17 more. $3 back and then 17 more. Okay, if I pay $5, if I win $5 but I paid $3 to be there, I'm really only winning $2. Is that all I have to account for? No, because what probability is it that I'm going to lose? The rest, and the rest is 28.36. So 2 out of 36, I'm going to win $17. Plus 6 out of 36, I'm going to win $2. Plus 28 out of 36, they're going to take my $3. And I'll win nothing. So that's how we would compute the expected. This will be on if you need to go. I'm going to post this. Maybe you can watch it with your sister. Hi, Cameron. She's probably like, I don't need to watch that. I've got this. That's what she's going to say. Yes. I feel like I've done something wrong. All right. Adios. 2 divided by 36 times 17 plus 6 divided by 36 times 2 plus 28 divided by 36 times negative 3. I have that my expected is negative 1.056. You can't, you don't want to round it too much. You know, likey? That means if you played this many times, the average amount of money a person walks away with is negative 1.056. So every single time a person walks up, some win, rarely, a lot of people don't win, and overall for each person that walks up, they're losing $1.056. The gambling company or whatever this is winning $1.056 on average for every person that walks up to play. So that's how they stay in business, because it's a game of chance and the odds are always in their favor, not yours. Okay. So it's always going to be a negative expectation. If it's a positive expectation, they couldn't keep their doors open. You're just gambling that you're one of the lucky ones. All right, here's the probability distribution function for a continuous random variable. Show that it's a legitimate density function. So do you remember how we did density functions? The area has to add up to 1 under the curve. So if you look at this, this would be, each of these blocks is like worth 0.1. So that's 0.5, 0.6, 0.7, 0.8, 0.9. This is 0.05 and this is 0.05, so it all adds up to 1. Okay, find the probability that it's between 0 and 3 inclusively. So the probability that you're at 0, that's weird. Probability of 0 is 0 plus the probability of 1 is 0.3 plus the probability of 2 is 0.3 plus the probability of 3 is 0.2, and that should add up to 0.8. Let me double check myself. Make sure I haven't done anything wonky. Yes. Say it again. Yeah, that's what I'm doing. I'm just counting. I'm counting my boxes too. I'm counting the value in each box since they go by tenths. All right, and then how about 2 to 3? So 2 to 3 would be me only adding up this and this. Go ahead. Hello? Yes. It just blows hot air around the room, but it's better than nothing. But it's crazy loud. Yeah. Okay. Okay. Got you. All right. Thank you. I'm tutoring. Okay. All right. Bye. Okay. So 2 to 3. We're adding up 2 and we're adding up 3. So 2 is 0.3. And 3 is 0.1 and a half, so it's 0.2. And that adds up to 0.5. It's really a weird question because they're giving it to you visually, but it's not that difficult a question. It's just weird looking, right? Yes. Okay, a manufacturer produces a large number of toasters. From past experience, the manufacturer knows that approximately 2% are defective. In a quality control procedure, we randomly select 20 toasters for testing. We want to determine the probability that no more than one of these toasters is defective. Is it a binomial distribution? State your reasons. What we got to look at B. What 2 options do we have? Defective, not defective. Well, I'm pulling out toasters and I'm going to take out 20, but they told you that they make a large number of toasters. So do you think it's safe to say the company makes more than 200 toasters if they make a large number? So 20 is less than or equal to 0.10 times a large number of toasters. That means I haven't oversampled my population. Remember, you cannot oversample. 10% rule. So BIN, how many toasters are they going to get out? 20 trials, that's set. And your probability of success, your probability that you have a defective toaster is what? 0.02 is defective every time. Yes?
So can we just write this on the test? Can we write
Yeah, you can write out bins. Determine the probability that exactly one of the toasters is defective. Is this a PDF or a CDF? PDF. This is a binom PDF that X equals 1. So I have trials 20, probability of success is 0.02, and the number of successes would be exactly 1. So that is 0.2725. That would be the probability that exactly one of those 20 toasters is bad. Define the random variable. X equals what? X equals the number of defective toasters. Okay? So X equals the number of defective toasters. And it says then find the mean and the standard deviation for X. Well, remember the mean is the probability of a defective toaster, which is 0.2, times the number of toasters we're going to test, which is 20. So the mean number of defective toasters is wait, it is 0.02. No, that's my bad. I just wrote a 0.2 because I was being goofy. I would say I was testing you, but we know better than that. And the answer will be 0.4, correct? Yes. And the standard deviation of X would be the square root of 20 times success, which is a defective toaster, 0.02, times failure, which is 0.98, and it's the square root of that. .626, okay? And find the probability that at most 2 of the toasters are effective. Nope, at most would not be a 1 minus. If it was more than, that would be a 1 minus. This is at most. So at most is telling you that it has to be less than or equal to 2. So what would success be? If I found 0, would that be a success? If I found 1, would that be a success? If I found 2 defective toasters, would that be a success? But what if I found 3? No. So failure would be if you found 3 or 4 or 5 or da da da. Okay, so success is me adding these together. And so that is binom CDF X equals 2. So my trials are 20. My probability of success is finding a defective toaster, which is 0.02. And my number that I would want to find is 2. And remember, it would add 1 and 2 and 0 together. My calculator will do it for me when I tell it CDF. .02 and 2. And the probability of this happening, of finding 2 or less, is 0.9929. Yes? Okay. We're getting close to being done. Oh, we got more word problems. That's a lot of word problems. That's good though, because then that gets you like super ready. Right. Okay. Draw a card from a standard deck of 52 playing cards. Observe the card. Replace the card within the deck. Count, and then of course you shuffle. It should have said then shuffle. Count the number of times you draw a card in this manner until you observe a jack. Is this binomial? No, because you have no set number of trials. You are going to pull cards until you have success. This is a geometric situation. You have no set number of trials. This is that fun friend. You're going to go and go and go and go and go until you get caught. No set number of trials. You pull cards until success. Okay, for these next ones, I'm just stating whether binomial is reasonable or not. The pool of potential jurors for a murder case contains 100 persons chosen at random from the adult residents of a large city. Each person in the pool is asked whether he or she opposes the death penalty. X is the number who say yes. Okay? So, are there two outcomes? Yes or not yes, which of course would be no. Okay, but I am sampling from a population. Could you say that 100 is less than or equal to 0.10 times the large city? Right? We know that's true. And how many people am I pulling? So trials are set. And then S, do you have the same probability that each person will say yes the whole time? We have to assume yes. What's a probability that you will say yes? Any person in this room? 50-50. So you have a 50-50 chance of success every time. Right? I don't know like what the true world population thinks, but I would say yes, this is a nice binomial question. You have a 0.5 chance of yes or no. Joey buys a Virginia lottery ticket every week. X is the number of times in a year that he wins a prize. So, B, what are Joey's two options? Win or not win? Are each of his tickets independent each time he plays? Each week is independent of the next. N, 52 weeks in a year. 52 trials equals weeks in a year. I agree. And what's my probability of success? They didn't quite tell us, but you know, if you look on the back of a lottery ticket and you buy one ticket from all the number combinations that there are, it is a set probability of winning. Okay, there's a set probability of winning.
So you don't always have to like give a number?
No. Okay, this is the last question? No. Oh, Lord. A fair coin is flipped 20 times. Determine the probability that the coin comes up with tails exactly 15 times. Is that PDF or CDF? Binom PDF. X equals 15. So, we have 20 trials. The probability of success is 0.5. The number of wins is 15. You just have to know that because you know if you flip a coin, it's a 50-50.
Oh, okay.
Yeah, so it doesn't tell you that. You just have to know that. 20 trials, 0.5 is success. The number of wins is 15 wins. And our answer is going to be 0.0148. Find the probability that the coin flip comes up tails at least 15 times. So success would be is 15 or more wins, correct? So if success is 15 or more, then success would be greater than or equal to 15. How am I going to do this with the binomial when it only works on less than? 1 minus binom CDF of x equals what? 14, because if 15 is a winner, don't subtract away 15. Subtract away 14. Oh, less than, yes, because it's a CDF. It's less than or equal to. Thank you. I did write that wrong. Okay, 1 minus binom CDF. I have 20 trials. My probability is 0.5, and my success value is 14. And I have 0.0207. The mean and standard deviation. My mean would be 20 times probability of winning, which would give me 10 wins. My standard deviation is the square root of 20 times success times failure. Square root of. So my standard deviation is 1.495. Oh wait, I didn't get that. I got 2.236. Did you guys get that? 20 times 0.5 times 0.5. Enter. To the 0.5 power, the square root of 5 is 2.23. I'm sorry, I don't know what my calculator gave me, but that was a boo-boo. Faux show, kiddos. 2.236. Find the probability that x takes a value within 2 standard deviations of the mean. Now, you already know what this is going to be. What's it going to be? 68%, and it's probably going to be 68.26 because I know that's 2 standard deviations kind of exactly, but this is what we would do. We've got the center. We want to know if this is 10, what's the probability of being within this from here to here? And this would be 10 minus 2 standard deviations. And this would be 10 plus 2 standard deviations. So I'm going to do norm CDF. My lower is 10 minus 2 standard deviations. My upper is 10 plus 2 standard deviations. My mu is 10, and my sigma is 2.236. And I have, oh, 2 standard deviations is 95%, y'all. It's 9545. I said 68 because I was thinking 1 standard deviation. This question said 2. So 2 standard deviations is 95% because we go mu, 68, 95, 99.7. Correct? Okay. All right, ready? Just a couple more and we're done. If you need to go, I understand. My little stars, they got to go dance, 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 dance. A headache remedy said to be 80% effective in curing headaches caused by simple nervous tension. An investigator tests this remedy on 100 randomly selected patients suffering from nervous tension. X would be what? The number of people who are the number of people who are what, cured with the remedy? Cured with the remedy. What kind of distribution does X have? It would be binomial. It would be binomial. Okay, if they said Y, it's because you have 2 outcomes. You're either cured or you're not cured. Each person's headache is independent, and we haven't oversampled the population, only sampling 100 people. The number of trials is set because we have 100 people, and the probability of success is 80% every time. Calculate the mean. So the mean would be, yep, 0.80 times 100. So the mean is 80. And the standard deviation is the square root of 100 times success times failure. And I have that it is 4. Determine the probability that it is exactly within 1 standard deviation of the mean. So you know that's norm CDF. Your lower would be 76 because that's 80 minus a standard deviation. Your upper would be 84 because that's 80 plus a standard deviation. Your mu is 80 and your sigma is 4. Yes, ma'am. No, because a binomial approximation like this can be approximated with a normal. That's just kind of a given fact. Okay. And we know we're expecting this one to be 68, right? Because it's 1 standard deviation. I said that earlier for 2. My B, 68.27. Yep. Use the normal approximation to find the area between 72 and 88. So this would be 72 and 88, same situation. And I have 0.9545. Is your result close to the empirical rule? Yes, it's 68, 95, 99.7. Bless you. Okay, we're about done. Yes, we're about done. And you guys will be really good. This is a lot of good stuff reviewed in this. A recent study revealed that a new brand of MP3 player may need to be repaired up to 3 times during its ownership. Let R represent the number of repairs necessary over the lifetime of a randomly selected MP3 player of this brand. The probability distribution of the number of repairs is given below. Compute and interpret the mean and standard deviation. So mu sub x, or mu sub r, right, since r is the variable, is 0 times 0.4 plus 1 times 0.3 plus 2 times 0.2 plus 3 times 0.1. And mu sub r, I have equals 1. Yeah, pretty fancy. Then the standard deviation is the square root of 0 minus 1 squared times the probability plus 1 minus 1 squared times the probability plus 2 minus 1 squared times the probability plus 3 minus 1 squared times the probability. Yeah, I just gave it all since we're doing this. But I am going to put it in my calculator. 0, 1, 2, 3, delete 2. And so my standard deviation is 1.
Alice Hart, if you're in the building, please dial 3000. Alice Hart, please dial 3000. Thank you.
Suppose we randomly selected a phone that may require repairs over its lifetime. The mean and standard deviation of the number of repairs for this brand of phone are 2 and 1.2 respectively. Assuming that the phone and MP3 player break down independently of each other, compute and interpret the mean and standard deviation of the total number of repairs. So the mean of x plus y is the mean of 1 plus the mean of 2, which will give you 3. The standard deviation of x plus y is the square root of 1 squared plus 1.2 squared. And I have 1.562. Each MP3 costs $15 and each phone repair costs $25. Compute the mean and standard deviation of the total amount you can expect to pay in repairs over the lifetime of the devices. Bye, honey. All right, so these are the repair costs. So the mean of X is 1. It's going to cost $15. So the mean for X is 15. And the mean for Y at 2 repairs times $25 is 50. So the total would be 65. For both of them together. The total would be 65 for both of them together. The standard deviation for X is 1 times the cost. The new standard deviation is 15. The standard deviation for Y is 1.2 times the cost. So the new standard deviation is 30. Now, to get the total standard deviation, or the standard deviation of the cost, sigma sub cost is the square root of 15 squared plus 30 squared. And that's 33.54. So that's the standard deviation of the costs. And last question. Mr. Voss and Mr. Cool bowl every Tuesday night. Over the past few years, Mr. Voss's scores have been approximately normally distributed with a mean of 212 and a standard deviation of 31. During the same period, Mr. Cole's scores have been approximately normally distributed with a mean of 230 and a standard deviation of 40. Assuming their scores are independent, what is the probability that Mr. Voss's scores are higher than Mr. Cole's on a randomly selected Tuesday night? So we're looking for the probability that their difference is greater than what? 0. So we want to know, so Voss's scores are 212. No, and Cole's scores are 230. So the mean difference of Voss minus Cole is 212 minus 230, which is negative 18. The standard deviation of the difference is the square root of 31 squared plus 40 squared. You never subtract standard deviations. So my standard deviations are 50.61. Now, we want to know what is the probability that the difference is 0. How likely do you think it is that Voss beats Cole? Does Voss normally beat Cole? No, because Voss is at 212 and Cole is at negative 18. So their mean differences are negative 18. We want to know when will their mean differences be greater than 0. We want to know this. So that's going to be norm CDF. My lower is 0. My upper is 10,000. My mean is negative 18. And my standard deviation is 50.61. And the probability that Voss beats Cole is higher than I thought it was. It's 0.3610 because there's a lot of variability. He has those good days too. That's it. All right, so